Hey, hello everyone. Welcome to another session of Lead Life Code. Today we are going to continue with our data structure series. This is the fourth session of data structure series, and today we will learn about the non-linear data structures. So in the non-linear data structures, there are primarily two types. One is the tree, and the other is the graph. So we will go into the details of both these data structures. Let us start with tree. So tree is a type of data structure which primarily stores hierarchies. So basically, you can think about a family tree or an organizational tree, the way the data is structured in them, right? In the form of levels and nodes. That is how a tree looks like. So in a tree, there is a root. So this, let us say this is the root. The root is basically the topmost node of a tree, and from that there are various branches that come out, which are which go into the child nodes. So these you can say as child nodes, and if there are more branches, then this becomes a parent of these child. Okay, and the connection that holds two nodes are called edges. These are called edges. So yeah, so these are the major parts of a tree. That is a root. There are nodes that are child and parent nodes. There is a node which doesn't have a child in them or no children with them, like this one. Then it is called as a leaf node. So a node with no children to them is called a leaf node. So yeah, these are the various components or main aspects of tree. So we'll go into what are the different types of tree that are available. So the first one that we will try to understand is the binary tree. Binary tree. So when we say binary, it is like two. So basically, the rule of a binary tree is it should not have any node, uh, should not have more than two nodes. Okay, the maximum restriction is two nodes. So this is what is called a binary tree, and the left hand side nodes are called left nodes, and the right hand ones are called right nodes. So these are basic nomenclature inside a tree. Once we discuss more, I will be using those nomenclatures just to keep you uh, up to date on the nomenclature that normally gets used in data structure. So let us go to the other one that is called binary search tree. So binary search tree, the difference between a binary tree and binary search tree is that the left nodes are always lesser than the parent. Okay, so that is the main difference. Basically, left child parent is lesser than parent, and it should be lesser than the right child. Okay, this is the basic rule on which the definition of a binary search tree comes up. Okay, let us go to the last couple of ones, that is heap. Heap is again one of the tree types. So heap is primarily used for priority queues. Okay, we'll not go a lot of into details for these ones. We will go into some traversal routines in tree. So, but just to give you an summary, there are majorly three types. One is binary tree, binary search tree, and heaps. There are few others. There is a balance tree. There is a trie, but these would be the primary ones, I think, that are used in the modern applications. uh, Now let us get into the traversal. What do you mean by traversal? Is how you access each of these nodes, the data of these nodes. Okay, so there is basically two types or two ways to do it. One is called depth first search, which is normally called as DFS, and the second is called breadth first search, that is BFS. Okay, so these are the two major uh, rules or types in which you can traverse through a tree. We'll just little bit try to get into a little bit of details of these two. So what do you mean by DFS? DFS. So in DFS, there is subdivided into three types again. There is a pre-order, there is a in order, and there is a post order. Okay, so I'll show you with some example on how this works. Let us say, I'll take a different color. Let us say you have a tree like this shape. I'll keep a very simple one. Okay, so this is 1 2 3 4 6 7. Okay, let us say this is the tree that we have got. Now as per pre-order, the rule that it follows is it first checks, goes to root, then goes to left node, and then goes to right node. What does that mean? So for pre-order, what does that mean is, let us say if you want to traverse through this tree, so it will first go to first node 1, then it would traverse to the left, that is left, that is 2, then it would traverse again, it will check the left. Okay, because now it became the root, so it will check the left one, so it will go to 3, then as it has checked all the left parts, then it will go to the right one, that is 4. So now if you see this hole is completed, it will again go back to 1, and then it will come to 5. So then left of 5 is 6, and then the remaining one, that is the right, is 7. So this is how it will traverse if it is pre-order. Got it? Now let us see how it will traverse if it is in order. So in order, the rule is left, root, and right. So same example, let us say, okay, so 1 2 3 4 5 6 7. So in order, what it will do is, let us start with left. So what is the left? If you go to the leftmost is 3, right? Then it checks from the root, what is the leftmost for it now is 2. After left, uh, it goes to the root. So for 3 it goes to root of 2, then from root it goes to right, so it comes to 4. Then it goes to the again the root, that is 1. Okay, from 1 again it comes to 5, but 5 is the right, so it will not go to 5. Then it will check what is there any left of it. Yes, there is a left, so it will go to 6. Then root of 6 is 5, and then goes to the right, 7. So if you see, the in order is 3 2 4, 3 2 4, then it will go to 1, then it will go to 6, 5, and 7. That is how the in order works. And the last one, that is post order. So here the rule is left, right, and then root. Okay. So in post order, what it will do is, it will first go to the left. Left is again similar to in order, it will start with 3, then it will go to 4, because after left it is right, so 3, and it will go to 4, then it will go to root of 3 and 4 is 2. Then again it will go and check what is the left. So here it will go to 1. Is there a left available for this? So it will come to 5. Then it will check, yes, there is a left available, so it will come to 6. Then it will see if there is a right available for this node. It will go to 7. Then it go to node of 7, that is 5. At the end it comes to the root node, that is 1. So yeah, these are the three types of traversals that happens inside DFS. That is the depth first. So basically depth means it goes through the tree in this order through the nodes. Now let us go to the BFS. So let us say BFS. So basically BFS is a level order. So if there is a node like this, so BFS means it will just traverse through the levels. This is level 1, level 2, level 3. So yeah, if it is 1, 2, 3, 4, 5, 6, 7, then it will traverse through 1, 2, 1, 2, 3, then 4, 5, 6, 7, 4, 5, 6, 7. So that is how it traverses through the breadth first order. Okay. So yeah, now let us jump into graphs. Graph. So graph is one of the modern most used data structures right now. So like in tree, what you used to do is hierarchy. In graph, it shows relationships. Okay, relationship. So what do you mean by the relationship here? So in relationship means, example, like in Facebook, you have friends, right? Friends in them, but you have also got mutual friends in them. So let us say you are one person, you have two friends, but your first friend and second friend, you are the, let us say, A, B and C. Okay, now B can also be a friend of C. Okay, let us say there are two more friends of B, D, E, F. Now D can also be a friend of F, and E can be a friend of A. So this mutual friends is basically showcasing a relationship inside a various nodes, inside the various nodes that are there. So this is one of the very important use cases in the modern systems, especially in social media systems or in your geolocations or your maps that are showing. I'll come to that, how it comes works there. But yeah, hopefully you got an understanding here. Basically, there is an interconnection that happens. And like in trees, these are also again called as edges. Okay, so let us jump into the various definitions and types inside it. So graphs are divided as, one is undirected. These are various types of graphs. The other one is directed. Then we have got weighted, and then we have got unweighted. Okay. So what does undirected means is relationship is uh, go both ways basically. Okay, it's like the example I showed you, the FB friends example. Okay, because you cannot be A can be a friend of A is a friend of B means B is also a friend of A. Right, that is the both ways there is a relationship. Now under the directed ones is one way. So this is example, I would say, the followers examples in Facebook and Twitter which you have. So if you are a follower of, say, a celebrity one and a celebrity two, it doesn't mean the celebrity one is again related to you. You are only one way related or following to that celebrity. So that is a one way direction relationship. Okay. Then comes the weighted. So here what happens is, like I said, there are edges So let us say you are traveling from a destination A to B, and B to C, and C to D, but D to A again you can travel. So here each edge is having a value to it. Edge has value. So what does that mean? So let us say to travel from A to B, it takes 45 minutes. From B to C, it takes 60 minutes. And from A to C, it takes 70 minutes. So if I have to ask you which is the shortest way, you will not say I'll go to A to B and B to C. You will say I will directly go from B to C, from A to C, because it takes the least amount of time. So this time is one of the value that is on this edge. Okay, so that is where I was saying where you are using maps for your shortest distance and all. Weighted is primarily used, and the last one is unweighted. This is just connections. Okay, there is no weight or no extra data that comes with the edges. Okay, so hopefully it gave you some understanding on the various use cases and different types of graphs here. And now let me take you to the way the graphs are structured, and how they are visibly uh, looked. So there are two ways. One is the adjacent matrix, and the other one is the adjacent list. Okay. So yeah, just matrix here is basically in the form of a table. It shows. So maybe in the future sessions I will share a little bit more details on how adjacent metrics and adjacent lists are portrayed in the real world. But for today, just understand that these are the two ways you can depict a graph. And from the traversal methodologies, like we have the BFS and DFS in trees. So here also we have this similar to DFS. So yeah, it again, this is like the level. So if you have multiple levels here, so like this it will traverse. And DFS, like we mentioned, the depth first search. Yeah, so this is used in recursions, the this DFS. And also maybe this is more in depth. I'll get into that in future sessions coming up. But yeah, for today I think this is all we have. I hope it gave you a good picture on the real life uh, practices and how tree and graphs are used in the modern applications, the digital applications right now. If you like this video, please subscribe it and stay tuned for more videos that are coming up in this series and in my channel. So thank you for giving your time patiently, and have a good learning phase. Bye bye.